Alrighty, we're going to talk a little bit more about trig identities just because I know that that's one of our biggest points of confusion and also where we could earn some more points. So I did hand out this formula chart. I don't know, it was last semester, who knows. And I think that if you can get some of these things memorized, which is much more straightforward than solving the math problem, just memorize these, you can earn a few quick points back. Because I went through the district test and a lot of those problems were ones that if you just knew what the identities were supposed to be, you could get a point back real simple without even trying to plug anything in. So again, there's lots of different identities going on here. The front page is obviously the more simple ones, whereas the back page gets more complicated, but USAD loves these, the sum and product. So if you can memorize those, then yeah, we might got a point or two coming to us. Okay, so if I look at this problem, which again was on the district test, it says which of the following trigonometric equations is not true. And this is set up a little bit differently than the ones on the ones on the formula chart. However, these are all just flat out identities. They're asking you, is this true? So you could plug in numbers and see which one actually works, but that's going to take you a long time versus taking a little bit of time right now and memorizing these sum and product identities. Okay, so looking at the sum and product, really what we're doing is we're just seeing, is this a true statement or not? So I have sine x and sine y, so plus. And if I look here, the only thing they've done is they've distributed the 2 underneath. So instead of having 1/2 of blah blah, so 1/2 of x plus y, they rewrote that as x plus y over 2. That's the same notation, they just moved it around a little bit. Okay, so if I look here, the sine x and sine y, you notice that there's a 2 in the front. There's a sine in here with a plus and a cosine with a minus. So this one is good. Okay, they just flipped it around a little bit. Okay, so that's all we're doing really is checking, is this true? So cosine and cosine, we notice that inside the cosine equation, there's both cosine. Both of these are the same on this side. We just have an x plus y and an x minus y. So they have a cosine here, plus minus, perfect. Okay, so if you notice here, when I have the sine ones, the cosine in there's both a cosine and a sine, versus when I have a cosine one, they're both cosine. Okay, kind of weird, but it works. Okay, so then if I have the sine minus the sine, again, I have a cosine and a sine, and the cosine is plus and the sine is minus. So that one is good. If I look at D, first of all, they're both the same variable. And I don't have one of these product identities or sum and product identities that have a sine and a cosine in them. So this one is kind of suspect already. So I'm going to go check the last one and then see if maybe that one's good and I can just automatically pick. So cosine x minus cosine y, cozy. Notice there's a minus on this guy. And again, it's a sine and a sine. So the cosines have the same trig function going on in them. So it's a plus and a minus, we're good, so it was D. So that one looked kind of fishy. Using our testing skills too, we might have been able to figure that out because that one is the one that looked the most different from all the other ones, at least on the left side. Okay, so again, that's a case of if I had those memorized, if I had those product and sum identities memorized, you would have just had this problem off the bat. So I think it's worth the time to invest going in and memorizing some of these because you can get at least 2 or 3 questions just knowing what they are off the top of your head. Okay, looking at the next one, so simplify this expression. So if you're someone you're familiar with the trig identities, you feel comfortable working with them, I would go and think about this odd and even thing going on. So all that these odd and evens are saying is if the function can fold over the y-axis and be the same on both sides, or if it has rotational symmetry. So really, if you remember that sine, cosecant, and cotangent and tangent, if there's a negative on the inside, the negative pops to the outside. Whereas cosine and secant, if there's a negative on the inside, it just becomes all positive because it's the same on both sides. So remember that cosine and secant are even, that'll make your life a little bit easier. So that negative really has no bearing at all for this problem. Really all this problem is doing is 1 over cosine x plus 1 over secant x plus 1. Okay? So if you knew that, you could plug into your calculator pretty quickly and test out those values. If you're someone you'd rather do the algebra behind it, you'd find a common denominator. So my common denominator is just going to be these two things multiplied together. So this first term is missing a secant, x plus 1, and the second term is missing a cosine x plus 1. Okay, So that makes my denominator, it's going to be that whole thing. And I'm going to go ahead and FOIL it out real quick. Oops. Just because I want to make this as fast as I can. So secant x times cosine x, secant x cosine x, and then I have a secant times a 1, and then a 1 times a cosine, and then a 1 times a 1. Okay, so that's my denominator. My numerator is just going to be these two things added together since I just had a 1. Thank goodness. So it'll be secant x plus 1 plus cosine x plus 1. Okay, here's where knowing your identities is again going to be helpful because secant times cosine, those two are reciprocals of one another, so that means that I can just cancel this out and get 1. Okay, so this entire thing is 1. So in the numerator, I have a secant and a cosine, and then 2 1s, so 2, surprise. And then in the bottom, I have a secant and a cosine, and 2 1s, 1 plus 1 is 2, so every single piece of this is going to cancel out, and I'm just going to be left with 1. Okay, if you're someone you're not comfortable using these identities, again, you can totally use your calculator on this, but remember, you have to pick a value and stick with it when you use this. So if don't try to pick 0 or 1 because sometimes weird things happen with those, but if you pick a number like 2, maybe 2 is your favorite, you can either just use the number 2 or you can store it as a variable. So if you hit 2 and then store it as my x or whichever letter you feel like, then that's going to, whenever I type an x, it's going to be a 2. So again, I can go through here and actually physically type this in. 1 over cosine of negative x. Please be careful of your parentheses. And then the one thing that's hard to do on these is to type in the reciprocals. So when I have a reciprocal function, notice you don't have a secant button here. So it's a reciprocal, it's a flip-flop. So secant is the same as 1 over cosine. So I have to make this into a really, really ugly big fraction. And then I press enter. This one was nice. It gave me a flat number. If you didn't get one and all of the answer choices were all trig expressions, again, just plug them in until you get the same thing. So this, if you're going to do the calculator method, you might need to save one of these problems till the end when you have like the extra time, which haha, extra time, but it might take you a little bit longer to do. Okay, let's do a couple more of these. Okay, this one, again, this is a straight up knowing your identities. So you can plug it in your calculator. No shame plugging it into your calculator. But if you take this and you distribute, I get secant x cosine x minus secant x. And we use the same identity in the last one, reciprocals. Wow, I didn't know where that was going to go. Secant is just 1 over cosine. So really, I have 1 over cosine times cosine, which, surprise, everything cancels, and I'm just left with 1. So this is 1 minus secant x, and here you go. And again, if you were to type this into your calculator, I'm just going to use the same x here. I would have to type in alpha y equals 1 over cosine x, and then parentheses cosine x minus 1. And this is going to give, I messed that up. I didn't close my parentheses, guys. I have to be more careful. I'm like trying to go fast. Okay, cosine x minus 1. There we go. So I get some sort of a weird number, and so then I'd have to plug in all of my answer choices until I found said weird number. Okay, so if I plug this one in, and this one was nice because it ended up being the first one, but it could take you a while to get there and find that those two things are equivalent. Okay, so again, this one's pretty basic. If you just know that cosine and secant cancel each other out and give you 1, then I could have just flew through this question and got to the next thing. Okay, this last one is pretty complicated. Okay, if you've been through pre-cal before, then I would assume that you probably have seen this very briefly, and I would expect you to be able to get this question, but if you haven't, honestly, you probably just bubble C and move on. But if you want to see how you do a question like this, they're asking you to find the subtraction of the inside. So when I look at that, there are actually some formulas on the front of your formula chart that say composite argument or sum and difference. So sine of m minus n would be the same thing as sine of a minus b. So this is a really long formula, don't get me wrong. However, if I have the sine of m minus n, that's equivalent to the sine of m times the cosine of n minus the cosine of m and the sine of n. So notice that for the sines, they have one of each inside of here. So they have a sine and a cosine, and then which number or which letter, which angle flip-flop. So it's going to be A and B and A and B every time. Okay, so sine has to go with the first thing, and then cosine has to go with this first thing. Same thing here. It's just now that there's a minus, we're going to subtract. Cosine is weird. Cosine keeps the same things together, kind of like in the half angle, or not the half angles, the other one we were talking about with the product to sum. But then you still have to flip these and have A and B, and then the plus is a minus, the minus is a plus. Tangent sucks. Yeah. So knowing this part of the formula, I now need to figure out what the sine of m and the cosine of n and all that stuff is. So I do know the sine of m. It's -8, whoa, over 17. I don't know I know the cosine of n, but I don't know the other stuff. So I'm going to need to figure out what these two pieces are. Okay, so it tells you what quadrants they're in. It says m is in the third quadrant. So I'm going to go ahead and draw that picture out. So this is angle M. And then they told me that the sine of M is -8 over 17. So opposite over hypotenuse should be -8 over 17. Okay, this is just using SOHCAHTOA. So now if I wanted to find this other leg, I could do the Pythagorean theorem, or if you know that this is a special right triangle, it's a Pythagorean triple, this last side will be 15, 8, 15, 17. Okay, so now that I have M, I can find the cosine. Again, I made this negative because I went left. So my cosine of M is going to be my adjacent over my hypotenuse. Okay, then I do the sine of N. So I need to draw my angle N. Oh, I wanted to make this a different color. There we go. Okay, so here's N. And then again, I know that the cosine of N, the adjacent over the hypotenuse, is 9 over 41. Again, this is actually nice in a Pythagorean triple. This is a 9, 40, 41. I know you probably don't know that one off the top of your head, but again, use the Pythagorean theorem. And again, since this one goes down, it's negative. So then my sine is going to be a -40 over 41, opposite over hypotenuse. And now this is just something I could type into my calculator and simplify down. Okay, I would honestly type this all in at once, because if you take the time to do each step, you might run out of time. So when I type this in, you don't have to use the parentheses. You can just type in with two separate fractions. So we'd have -8 over 17 times, this is the part that takes me the longest. I think you're faster at typing on your calculator, at least I hope you are. And then this is a minus in between, be careful. And then I'd have -15 over 17. And again, I would recommend typing all of this in at once, not to take each piece, just in case you accidentally lose a negative or something somewhere. -40, maybe, over 41. I hope that's what I had on my paper. Let's find out. Yeah, I got it. Okay, and then I'm going to press enter, and it should simplify your fraction down, just because that's how I typed it into the calculator. Okay, if you typed in each of these pieces individually, you might have to do the fraction thingy and make it into the simplest fraction you can, but hey, yeah, I have that answer. Woohoo. Again, I think that one's a super complicated question. This one would take a lot of time. Notice how long it took me to do it, and I had the formulas in front of me. So try to memorize those formulas as your first goal, and then how to apply those formulas would be the second goal.